guys, in this video I'm going to discuss the problem of circular convolution. The first question in our mind arises, what is convolution, right? Convolution means convolving the two signals. Might be you have studied in the wireless communication, right? Either in analog or digital communication. So we need to convert two signals, right? So again, in the convolution there are two methods are there: linear convolution method and circular convolution method. Okay, based on the requirement and application, so we can use either linear convolution or circular convolution. In this section, the important question is the difference between the linear convolution and circular convolution, and problems are also important. Might be in either our question they will ask the question from linear convolution. The main question is problem. They may be asked for 8 mark questions. Okay, for 8 mark question they may be asked linear convolution or circular convolution. For 2 mark questions they will ask the difference between the linear convolution and circular convolution. I will discuss the difference between the linear convolution and circular convolution in the upcoming videos. Will get You will get the answer in the Nagur Khani book. Please follow that book for this question. Okay. For after the each chapter, at the end of each chapter, they have given some set of questions. Kindly read those questions and with answers. Okay. And also another important thing is they will mention the Anna University questions with answer in the Nagurkana and Chittor also. So while studying the each chapter, mainly concentrate on the problems based on this. So they have mentioned the Anna University question with year. Okay, please concentrate those problems and solve and practice those problems many times. Okay, the percentage of asking question such type of question is more in your exams. Okay, so concentrate and study well from the exam point of view. So today we will discuss the circular convolution. Okay, so we can solve the problem circular convolution in different method. Okay, so first method is graphical method, second matrix method, third DFT IDFT method. You know very well, DFT means discrete Fourier transform, IDFT means inverse discrete Fourier transform method. In the exam they won't ask solve the circular convolution using graphical method, matrix method, or DFT IDFT method. Okay, they will ask solve the circular convolution for the given sequence. So you can apply either graphical method, matrix method, or DFT IDFT method. Okay, so personally I will prefer to solve the circular convolution using matrix method. This method is very easy to solve the circular convolution. Okay, so we will see one by one. Okay, first we will discuss the graphical method of solving the circular convolution. Okay, so here I have taken one problem. So here they have given two sequences, right? X1 of n sequence 2 1 2 1 and x2 of n sequence 1 2 3 4. So we have to convert these two sequences, or these two signal, or these two discrete time sequences. Okay, mathematically we will represent the circular convolution in this way. This is very important. There is a difference is there in the representation of linear convolution and mathematical representation of linear convolution and circular convolution. Okay, This is the mathematical representation of circular convolution. Maybe it differs here. Okay. So here, there is one circle. Inside the circle, they have mentioned n. This is the representation of circular convolution. We can also call this one a modulus, right? You have studied in maths as a modulus of n, right? Modulus 3, modulus of 4, like that. Here, it is a modulus of n point, right? So this is the mathematical representation of circular convolution. Okay. So here the endpoint is 4, right? 1, 2, 3 and 4. The endpoint is 4. Okay. So again, we can't apply the values in this mathematical representation. The convolution equation is this one. Okay. This is the convolution equation. Okay. x3 of m summation n is equal to 0 to capital N minus 1 x1 of n x2 of m minus n of 4. Okay, m is varies from 0, 1, 2, 3 and so on. Okay, m is varies 0, 1, 2, 3 and so on. Okay, so see here, first we have to represent the sequence in the circular way. Okay, so there is no any condition, so we have to take inside the circle this one and outside the circle this one. You can take any sequence in any one of the circle. Okay, you can take this one as inside, this one is outside. There is no certain condition. Okay, but there is some procedure is there to solve the from just you have to follow that procedure to solve the circular convolution using a graphical representation. Okay, so see here, this is the equation. Okay, you have to write this is this one and this one. These two equations are very important. So see here, so I have taken the first sequence x1 of n sequence inside the circle and x2 of n sequence outside the circle. Okay, so and also this this x1 should have to represent in this place. There is no such type of conditions. Okay, you can represent anywhere. Okay, you can also represent x1 of 0 here or here or here. It is up to you, but some conditions you have to follow. See here, I have taken here x1 of 0, but x2 of 0 also you have to represent here itself, right? If you are representing x1 of 0 in this portion, but x2 of 0 is also you have to represent in this place. Okay, so then you have to uh, in the anti-clockwise you have to represent the x1 of n sequence. Here this is a x1 of 0, this is anti-clockwise, right? This is anti-clockwise, this is x1 of 0, this is x1 of n, this is x1 of 2, this is x1 of 3, right? This is an anti-clockwise, but while representing the x2 of 0 you have to represent in clockwise, right? So this is x2 of 0, x2 of 1, right? So it goes like this, x2 of 2 and x2 of 3. This is the first step. Okay, this is the first step. So but here we are not calculating anything. By using this graphical representation we are calculating the first sequence. Okay, x3 of 0. Okay, so here see here, so I am delaying the outer circle. This is a delay representation. Okay, this is the delay representation. So I am going to fix x1 of n. So I'm not going to rotate x1 of n. Just I'm going to rotate x2 of m minus n. Right? It is a delay element, delay variable. So I have to rotate in the anti-clockwise direction. Okay, I have, while writing the values, so x2 of n I have used clockwise, but While rotating the x2 of n sequence, we have to rotate while making or while doing delay, so we have to rotate in anti-clockwise. Okay, so this is anti-clockwise. I am fixing x1 of n, so just I am rotating x2 of n sequence. See here, I am not rotating 2 2 1 2 1. This is the x2 of 0 value, x1 of 0 value, this is the x1 of 1 value, x1 of 2, this is x1 of 3. These are fixed. Just see here, here the x2 of 0 value is 1 because of delay 1, so it goes here. See here, 1 here, 4 here, that 3, this values come here, and this 2 value is goes here. Okay, just I am rotating anti-clockwise only. It represent delay by 1. Okay, delay by 1. Okay, so after that I have to multiply these two numbers, then I have to add 2 2s are 4. See here, 2 2s are 4, right? 2 2s are 4. Then this is 1 1s are 1, right? So 4 2s are 8, 3 1s are 3. So after adding all these elements, I will get 16. This is x3 of 1. So this is x3 of 1, right? This is x3 of 0, sorry. This is x3 of 0. The first graphical representation is x3 of 0. This is x3 of 0. This is x3 of 1 calculation. Where I am going to delay by 1 element. Here I am not delaying anything. So that's why this is x3 of 0. So see here, 2 1s are 2, right? Just make it here. This is 2 1s are 2 plus 2 1s are 2 plus 3 2s are 6 plus 4 1s are 4. 6 plus 4, 10. 2 plus 2, 4. 10 plus 4, 14. So x3 of 0 is 14. Right? This is x3 of 1 is 16. Similarly, I am going to delay. If we are delaying this one means it is 2. If I am going to delay this by using this figure, I have to delay by 2. So I'm not going to use this figure. Okay, I'm not going to use this figure. I'm going to use this figure. I have already delayed by 1. So again I have to delay it by 1. Then it becomes delayed by 2. Right? So just rotate this. This 2 comes here. See here. 2 comes here and 1 comes here. I have 1 in the previous. I have 1. So it comes here. This 4 comes here. See in this figure. That's all. So I am not going to rotate this one, right? Just I am going to rotate exterior of the circle. Then I have to multiply these two values. Then I have to add all the numbers. You will get 14. Similarly 0 1 2 3. So again, so I have to calculate x3 of 3. Similarly again I have to rotate anti-clockwise. This one I have to rotate anti-clockwise. This 3 comes here, 2 comes here, this 1 comes here, this 4 comes here. See here. Now so I am fixing the interior circle. Then I am multiplying this 2, this 2, this 2, this 2. Then I am going to add all the numbers. plus, then the final value is 16. So x3 of 0 is 14, 16, 14, 16. This is the circular convolution output using a graphical representation. Try to solve more problems based on the graphical method of circular convolution. So you will get questions in Nagurkani book, Chittood book, refer those book, and also refer the Ramesh Babu book. Thank you very much. Hope you will understand this problem. Happy learning. Thank you. In the next video, we will discuss a matrix method based circular convolution problem. Thank you.